Hi students, welcome to Time. In this session, we will be discussing about measurement and motion, physical quantities and system of units. So, that is the topic what we are discussing today, right. So, when you are talking about measurement, we do come across measurement in our day-to-day life activities, day-to-day activities. From the day we wake up from our bed till the time when we go to bed, there are so many activities what we come across and where we come across these measurements, right. For example, when you wake up from bed, the first activity what you do is this, brushing the teeth, right, to get ready for the school. So, you will be able to measure the amount of paste what you will be putting on the brush. That is simple now, right. You will not put too much quantity or too much less, approximately that much, whatever it is suitable to your brush. That is one thing. Suppose after this, okay, I want to take some cup of milk or something like that. So, you will take the milk over there, you will try to measure that. Suppose your mother is little bit increasing a little bit on any particular day, like a holiday or something like that, you will simply deny it. You will say you have given too much of milk and you can't take it. That means what? It is increasing your regular quota, right? So, you will not prefer to take extra quantity. Or let us suppose you are not taking milk, you wanted to have a cup of coffee or tea, then the amount of sugar what you are putting on the cup of coffee or tea, that also you will measure, 1 spoon or half spoon or 2 spoons, 1.5 spoon, something like that. So, this is also you are measuring it, right. Suppose you wanted to get ready for the school, it is becoming time is up. So, you will measure the time over there. And the distance is very far, you will try to measure the distance also. And finally, you have a whole load of luggage over there, right. The baggage, your baggage what you carry to your school. So, in all these activities, you are trying to do what? Measurement. Then, did you ever think about what exactly is this measurement? No? Let us give a thought. There are so many things what we measure in our day-to-day life. That is what we discussed so far, right. So, let us see some of the activities where you will try to measure the length. See here, we have so many icons related to measurement of the quantities as well as some of the devices over there, right. Let us look at some of them. Let us suppose here I say, this is the length of a crayon I am trying to measure with the help of a scale. And here, the length of a pencil, I am trying to measure it with the help of another scale like this. I am trying to measure what length? Fine. Let us take one more example here like this, where this will be used in either in a kitchen in your home or generally in the hotels, where the chefs try to do the prepare the materials based on the weight. They will have some standards, right? How much vegetables or how much weight of the vegetables have to be cooked for a particular dish. Like that, they will be trying to measure it. That is one thing. And similarly, see, if you are trying to measuring the volume of liquids, there are some colorful liquids out there. You have different containers where you have measuring the volumes. Say this is 1000 ml beaker, this is say 500 ml beaker, something like this. You have different devices where here what you are trying to do, you are trying to measure the volume, right. Similarly, have you ever done this type of activity? You think you are grown up, right? So, when somebody says that you don't know you are a kid, you will try to express yourself, no, I am grown up, I am old, this much height, see. That is what you try to have a gesture, right? Yes or no? Now, in all these activities, what you are trying to do is measurement. Now, for example, if I wanted to understand what exactly is measurement, look at this boy here, he is trying to measure his own weight. What is he doing? There is a scale drawn up on the backdrop over here, maybe on the wall, and he is trying to stand beside that and trying to put his hand over his head and trying to measure it. Let us say his height is say approximately 138 centimeters. So, here I am talking about two things. What is that? One is the height of the boy, another is the centimeter. So, this is one physical quantity. What I am trying to measure is centimeter, and this is 138 times. This height is 138 times 1 centimeter. So, what I am doing? I am comparing two things. What are the two things? One is the height of the boy, second is what? Centimeter, right? So, when I am trying to compare these two, then what I am trying to do? I am trying to measure. So, this is exactly what is measurement. Okay. So, now how can I define it? So, measurement can be defined as a measurement of a quantity is comparison of the quantity with another one, which is usually a standard. What do you mean by standard? Centimeter is a standard. So, if at all I wanted to measure the length of this boy with another unit, say my hand, I can say this is the hand span from one edge to other edge of the tip, from thumb to the little finger over here. So, if at all I wanted to measure, I can measure with the hand span over here. But will it be a standard? Definitely not, right? So, my hand span will be a little bit longer compared to your hand span. In such case, I cannot say, okay, the length of this boy is say 10 times my hand span. So, we need to go for a standard which is acceptable. That's what you say, it is centimeter. Okay. So, basically what we understand is measurement of a quantity is comparison. Comparison of what? One physical quantity with another physical quantity. That another physical quantity, whatever you are taking as the reference, is the standard. Okay. Let us look at some more examples here. So, when we are trying to measure length, we will take the help of a scale and try to measure the length. Okay. And say, I wanted to measure the quantity like this, dosa. What is this? A food item we are trying to measure. What we are trying to measure in the food item? Suppose I wanted to, a chef is making a dosa or something like that. What he will do? He will take some batter and then put it on the tawa, right? So, he will use the ladle, say 1 scoop or 2 scoops or something like that. So, based on the size of it, so he will try to measure the quantity of batter that will be used. That's what he is trying to measure over there. Similarly, I have to measure the water what we take in. As a health consciousness, we generally need to take at least minimum of 4 glasses of water per day, right? Yes or no? Otherwise, what will happen? It will lead to some diseases, water shortage. So, we will try to measure the amount of water also. Clear? And another activity what we generally come across is this was where you will try to measure the weight. So, you will try to measure, check your own weight now. You will stand on the weighing scale like that and then try to check. Okay, maybe the weighing scale may be digital one or a analog one, whatever you call. Okay, so there is a usual activity sometimes in the schools where they will try to measure the children's height as well as weight as a regular health checkup, right? You would have also gone through it once in a lifetime, right? Yes or no, so far. So, similarly, I am trying to measure these things. These are some of the things. Similarly, if I wanted to measure the area, so area is also one physical quantity what you can measure. So, we have so many physical quantities what we are measuring, but do we also have some quantities which we cannot measure? Give a thought, right? Just pause the video for a while and then think about this. Do we have certain quantities which we cannot measure? Okay. Now see, these are the certain things: faith, hope, anger, affection, like. If I say, if I am liking this particular vanilla ice cream, I like it very much. When I say I like it very much, I cannot say how much I like, right? A particular flavor of an ice cream or a particular dish, how much you like it? You don't know, you cannot say. Same way you like your friends or you like your parents, you cannot say how much you like them. Okay, if somebody is scolding at you, you will get an anger. How much? You cannot measure it. So, those quantities you cannot measure. That means there are certain things which we cannot measure also, right? So, on the whole, if you categorize it, we do have two things: some things which can be measured and some things which cannot be measured. So, the things which can be measured are called as physical quantities. Okay. So far, we discussed just some of the physical quantities that we can measure it. And we also seen that measurement, the physical quantities are the quantities which can be measured. Okay. Let us see a few examples of these things. Like for example, if I wanted to measure the length of a scale, length of a pencil, what will you do? I have a pencil over here. I'll take a scale and then put it besides it and then try to measure its length. Okay. So similarly, I wanted to measure length of any object. That means we are trying to measure length in one particular direction. So that is what we call one dimension. Suppose I wanted to measure the length of an area, right? So I have to measure the total length as well as in the breadth also. Breadth may be also a length, no doubt about it. But what is it? It is in the other direction. It is not in the same direction as that of length. So whenever I wanted to measure the area, I need two dimensions over here. Measurement of length in two dimensions. One is along the length, other is along the breadth. Right? For example, if I take the length of a rectangular area over here, it is 3 units and this is 2 units, then I will measure area as length into breadth. So how many units I will get here? Obviously, it is like 3 into 2. You know that, right? 6 square units. So wherever I am talking about area, we will take it as square units. And this is the linear one, straight single units only. Whatever may be the unit you are taking. Now, the difference between these two is, here I need to measure the length in 2 directions. Here I am measuring in only 1 direction. Now, let us take an example of another case where we need to have measurement in 3 dimensions. What do you call this? A cuboidal shape. So, you can see here very clearly the dimensions are shown. I am just trying to rotate it so that you will be able to see this is the length, this is the thickness, this is the breadth one over here. So, what is the primary property of this cuboid? Guess it? Yes. So, it will be basically volume. If at all I wanted to measure the volume of this, what I need to do? I need to measure the length in one direction, this is this way, breadth in this way and height in this way. That means I do have measurement in length in 3 different directions. That's what I mean to say, 3 dimensions. Clear? So, this is one particular physical quantity. Fine. I know now how to measure the volume of a body. Let us look at some more physical quantity which is fundamental or which is not fundamental, which is essential for almost all the materials. That is nothing but density. If at all I wanted to measure the density of a material, what I need to know? I need to know its mass. I also need to know its volume. Okay. Now, can you tell me how do you define density? Yes, you are right. Density is mass per unit volume. Mass divided by volume. So far we have seen that in physical quantities like say length, okay, and say breadth, you are talking about area and you are talking about volume, density, temperature, mass, okay. These are some of the quantities what we have. These quantities, if you see, they are fundamental physical quantities. Why they are fundamental? Because to measure these quantities, we need not depend on the measurement of other physical quantities. That's how the definition goes, that the physical quantities whose measurement is independent are called fundamental physical quantities. Okay. So, if at all I wanted to measure the length or breadth, both mean the same again. That means breadth is also a length, temperature, mass, time, so on and so forth. We do have certain physical quantities whose measurement is independent. Means in order to measure those things, we need not measure any other physical quantities. But when you consider area, volume, density, okay, so many are there like this. If at all I wanted to measure area, I need to depend on 2 things. One is the length of the body, another is breadth of the body. Then only I will be able to calculate the area of the body, right? So that is one thing. Similarly, volume also same thing. So now we'll define what is it called derived physical quantities. So all these three will come under this category. Physical quantities whose measurement depends on measurement of other physical quantities, they are called as derived physical quantities. So this is how we differentiate any physical quantity into either fundamental or derived. We have seen some physical quantities, okay, whose measurement is dependent on some physical quantities and whose physical quantities are not dependent on some other measurement of some other physical quantities. So basically, when you say physical quantity is like measurement of a physical quantity, we know that it is a comparison, usually a standard. Now we try to focus on what is this particular standard, right? Suppose I say standard is nothing but a unit. Why it is a standard? Because if I wanted to measure that particular physical quantity, I will measure it in multiples of this unit. That is the reason it is called as a standard. Okay. Now let us look some examples. If at all I am measuring length, I will measure length in terms of meter, centimeter, kilometer, etc. Okay. Similarly, if I wanted to measure mass, I can measure it in terms of grams, centigrams or milligrams or kilogram, quintal, ton, etc. All these will be the units of mass only. Same way with the temperature, time, if I wanted to measure, I can measure in terms of second or minute or hour or day, year, etc. All these will be the units of time. Okay. These are some of the physical quantities what we have seen whose measurement is not dependent on the measurement of other physical quantities. And these are corresponding units of these particular physical quantities. So we will call them, these are fundamental units. Okay. That means units of fundamental physical quantities, they are called as fundamental units. Now on the other hand, we do have certain physical quantities like area. And what is the unit of this particular area? If length is measured in meter or centimeter, kilometer, something like that, so what will be the units of area? Have a small guess. Yes. Similarly, square centimeter, square meter like this, or square kilometer, if the area is too large, we can measure that way. Okay. Similarly, I will go with volume. Okay. When I wanted to measure the volume, I can measure it in terms of cubic centimeter or cubic meter, cubic feet, whatever it is. Okay. All these will be the units of volume, right? Similarly, if I take say density we have just seen that it is nothing but mass per unit volume. So mass per unit volume, how do you get the units of that? If I know the units of mass and units of volume, then I will be able to calculate the units of density. Okay. So that I will get it as gram per cubic centimeter or kilogram per cubic meter. Now, all these are the units of what are these quantities called? Derived physical quantities. So what do you call these particular units? Like whatever you have categorized these units as fundamental units, then how do you name these things? Have a guess. Right. It is nothing but derived units. Units of derived physical quantities are called derived units. So, like you categorize physical quantities, that means which are measurable, into two categories like fundamental and derived, you can also categorize units into fundamental and derived units. Students, we know that fundamental physical quantities are the quantities whose measurement do not depend on the measurement of other physical quantities, and derived physical quantities are the physical quantities whose measurement depends on the measurement of other physical quantities. Now, the fundamental physical quantities, if I take like length, mass and time, basically we know that in order to measure them, we have certain units like millimeter, centimeter, kilometer, etc. Similarly, for mass, we do have several units like gram, kilogram, etc. So, all these are the units of these quantities. So, when we take all of them collectively, then we will call them as system of units. The units of the measurement and the rules but relating them to each other, that is what you call it as system of units. Now, to understand the system of units, we will take basically three physical quantities, say length, mass and time. Okay. Length, mass and time, these three physical quantities we will take, and we will try to define each system of units. For example, if I wanted to measure length in terms of centimeter, mass in terms of gram and time in terms of second. Okay. So, you can see very clearly now length is measured in centimeter, and for volume it is length into length into length, right. So, I will take it as centimeter cube, gram per centimeter cube. That is how I will measure density. Suppose I wanted to measure speed. Speed is distance by time, we know that. So, I will try to measure speed in terms of centimeter per second, because it involves length as well as time. So, like that, every other derived physical quantity, if I am expressing them in the units of length, mass and time, whatever I take, centimeter, gram and second, that particular system of units you will call that as CGS system. Yes, you are right. C for centimeter, G for gram and S for second. That is how it is evolved. Okay, this is one system of measurement where we will take these fundamental physical quantities and these fundamental units. Now, if at all I do use a different unit to measure length other than centimeter, like say for example foot. Similarly, for mass, I do not use gram, I will use pound. Okay. Similarly, for say time, I use second. Then what is happening? For measuring the speed, I will measure it in terms of feet per second. If at all I wanted to measure density now, it will be like, what will be the unit? Yes. Have a guess. In terms of this, it was like gram per centimeter cube for density. Now, in this particular thing, what will I get? Mass is measured in pound and length in foot, right? Yes, you are right. So, it is pound for feet, cubic foot. Okay. So, similarly, speed as I told you, feet per second or foot per second to be precise. Okay. So, I am measuring the fundamental quantities in these three fundamental quantities in these three units, and any other derived physical quantities, I am expressing them in terms of units of these particular units. So, this system of units, obviously what will you name? Yeah, you are right, FPS. F for foot, P for pound and S for second. Okay. Now, similarly, I do have one more system of units where I will measure the length in meter, I will measure the mass in kilogram and I will measure the time in second as usual. Okay. Then this will be called as, yes, you are right, that is MK, system of measurement. Okay. Now, three different systems of units. Is there required? Do we require these three systems of units? Why can't I go with one particular system of units? So, every country or a different nation is following a different system of units. It is their choice. Now, I will show you one thing, right? I will show a flag over here. This is a flag. This flag